Cameron throws a rock off a bridge into the river below. The rock's height above the water in yards, h of x, depends on the time in seconds after throwing x and can be modeled by the function h of x is equal to negative 5x squared plus 10x plus 15. What is the initial height of the rock? How many seconds after the rock is thrown will the stone hit the water? How high is the rock 2 seconds after it was thrown? At what time will the rock be 10 yards above the water? And interpret the average rate of change between 1 second and 2 seconds. So when I see this problem, the first thing I do is I go ahead and highlight the important information. So to me, what's important is the rock's height above the water. So our rock's height above the water is h of x, and it's measured in yards. And then also time in seconds is after throwing is our x. And then we've got that equation. So we should go ahead and pop that equation into Desmos. Please pause your video and do that now. So here is the equation in Desmos. And if I see it right now, I know it's a quadratic because it's got the x squared, so it should be a parabola. But right now it's not a parabola. So I need to make sure that I'm zooming out, or I can't see the parabola. Let me rephrase that. It is a parabola, I just can't see it. Okay, so if I'm zooming this out so I can see it, I might even pull this down a little bit and zoom in. Okay, I can see all this extra space. So look at all this space right here. So right along this whole line, right, I can cut this off. So I don't need to see anything past 5. So on my tools, I'm going to change it so I don't see anything past 5. Okay, we're going to do the same thing on this side. I don't need anything past negative 5 on this side. So I'm going to go ahead and cut it off at negative 5. Okay, so that looks like a pretty good picture. I'm going to put in my labels. So I said my x represents time in seconds, and my y represents height in yards. Okay. And I could even cut this off more if I wanted. I could cut it off at negative 2 instead. Looks like there's a lot of extra space over there. Okay, so that looks pretty good. I'm going to look at my important points. So this point is telling me negative 1 seconds is 0 height. So I'm probably not going to talk about negative 1 seconds after I threw the rock. So that point is not important. This one says 0 seconds, the height is 15 yards. This point tells me after 1 second, the height is 20 yards. And this one says after 3 seconds, the height is 0 yards. So I'm going to go ahead and add that to my picture. So let's start answering the first question. It says, what is the initial height of the rock? So initial is one of those words that gets people tripped up often. Initial just means starting. So where did the rock start? Okay, if I'm talking about my starting point, that means my time is 0. And my time is my x. So that means x equals 0. So I'm looking for x equals 0 on my graph, which is right here. So it looks like it starts right here at 0.15. And they are asking, what is the height? So that's my y. So the height is 15 yards. Next up, it says, how many seconds after the rock is thrown will the stone hit the water? So they're asking me for how many seconds. So that's an x. And they're saying the stone will hit the water. So they're telling me the height of the stone hitting the water is going to be 0 yards. So that means y equals 0 this time. Right? And I've got a place right here where y equals 0. So this is where the stone hits the water. Stone hits water. Okay, so it's at 3, 0. So the time that the stone hits the water is 3 seconds. question asks is, how high is the rock 2 seconds after it was thrown? So they give us 2 seconds, which is an x, so we know x equals 2. Looking at my picture over here, I don't have any points that say x is 2. So I'm going to go ahead and I'm going to type it in Desmos. So on Desmos, I'm typing in x equals 2. Okay, and I've got the point 215. I'm going to make sure I sketch that on my picture as well. So I know 2, it's right here at 215. So after 2 seconds, my rock is 15 yards above the water. Okay. At what time will the rock be 10 yards above the water? So this time, they're telling us 10 yards above the water. So that's a y equals 10. And again, I just look at my picture. Do I have any points that has a y of 10 right now? I don't. So I'm going to go ahead and type it in. So on Desmos, y equals 10. So it looks like they're crossing in 2 points. I've got this negative 0.4 and I've got positive 2.4. Now here's the deal. We're starting with time. Time can't be negative, so we're going to ignore that point and we're only going to pay attention to this point, 2.410. So I'm going to put that on my graph. There's my y equals 10. So it's 2.410. 2.410. And the question is, at what time? So the time is going to be 2.4 seconds. And this last question says, interpret the average rate of change between 1 second and 2 seconds. So they're telling us 1 second, 2. Those are seconds, so they're x's. X equals 1 and x equals 2. So if we look at our picture, we do already have 1 and 2. Okay? And they're asking us to find the average rate of change. So that's the slope. Okay, we could do it a couple of ways. We could do rise over run. We could do our Desmos way with our cheat code. We could subtract the y's divided by subtracting the x's, so the change of y over change of x. So let's set up our table to do our cheat code. So on our table, we're going to put our 2 points, 120 and 215. And like always, our cheat code is y1 tilde mx1 plus b. And so if I type that into Desmos, I've got 120, 215. You could see they lay right where I said they were going to lay. Okay. And our cheat code. Our slope then is -5. -5. This question doesn't just say find the slope. It says interpret the slope. That's our buzzword. So we know slope is always rise over run. So our rise this time is talking about height, okay, and our run is talking about seconds. And remember, anytime we talk about slope, we're using the word per. So in order to talk about this -5, we're going to say the rock, let's see, does it go up or does it go down? It's negative, so it falls 5, and then we got to do our rise over run. 5 height, so 5 yards per, and then whatever our run is, which is seconds. So to interpret it, it says the rock falls 5 yards per second. Sorry, not seconds. So 5 yards per second.